Okay, the name of the game in this section, we want to factor trinomials. And the goal is to factor degree 2 polynomials of the form ax squared plus bx plus c. A, b, and c are all constants. When the leading coefficient is 1, that means a equals 1. There's a systematic method to factor these guys. By the way, let's make sure you understand what I mean by a, b, and c. What's a for x squared plus 7x plus 12? What's a? A is the coefficient of the term of highest degree, so that's going to be x squared in this case, and the degree is 2, and a is 1. What's b? The coefficient of the x term, or the variable to the first power, and c is 12. When a is 1, I don't want to say it's easy because when you get big numbers, it's not easy, but it's straightforward. The method is systematic. So basically, you reverse FOIL. So what does FOIL stand for? So that has to do with multiplying binomials together, right? And the F stands for first, meaning you're going to multiply if you have two things that you're multiplying together. Let's just say 3x plus 2 has nothing to do with this example. 3x plus 2 and x minus 1. When we say the first terms, it's the first guy here and the first guy here, right? First, and then outer terms. Okay, the outer, that would be also an outer, but this would be the other outer, right? And then what does I stand for? Inner. So these two guys, and whoops, put the R in a weird spot right there. And then L stands for last. So the last term here times the last term here. We're going to reverse that. That's the idea here. So I just made up those numbers. It has nothing to do with how the first one factors. So how do you reverse FOIL? Well, the first thing I would do is I would set up two parentheses. And think about the first terms. To get an x squared, I mean, isn't that how you get the term in front? Is to multiply the first guys together, whatever they are? So what would you have to have here and here to get an x squared? Yep. X both times. Okay. And then what about the guy in the end? How do we get the 12? It would be the L's, right? The last multipliers. To get the right number here, we need a number here and here. The last multipliers, we need those to multiply together to make 12, right? But if you think about the outer and inner terms, in a situation like this for a degree 2 polynomial, the outer and inner terms will be like terms, and they have to add together to be that middle term, in this case 7x. So the method is this. You find two numbers whose product is the last number 12, and whose sum is the coefficient of the middle term. And you might know what those are right off the top of your head. 3 and 4. So reverse FOIL gives us x plus 3 times, as a quantity, times x plus 4. Let me write down that method for you. The main method is reverse FOIL, so in step 1, set up two sets of parentheses. And then when this works when a equals 1. Your two sets of parentheses will be of this form. It'll look like that, and then you'll automatically set it up to be x times x. That's how it'll be every time for the first term. And then to finish off the reverse FOIL, you find two numbers whose product is equal to c, right? C in this case is 12, and whose sum is b. B in this case is 7. And then, of course, fill in the rest of the parentheses with those two numbers. And you got to make sure you get the right sign, right? If everything's plus, it's not a problem. But if you have a minus in there somewhere, you have to think about it a little bit. Okay, so fill in the parentheses, and you're done. Okay, so go back and look at what we just did. X squared plus 7x plus 12. We set up the two parentheses. First terms, we got x and x, and then we found two numbers whose product is equal to c equals 12 in this case, and whose sum is equal to 7. In part B, 2y squared minus 2y plus 12, you look at that and you say, oh, what's a equal to in this case? 2. So that method I just gave you is out the window. Well, there's an even greater rule here. Whenever you're dealing with any kind of polynomial that you want to factor, you always factor out the GCF first if it's something other than 1. If you look at the last problem, was there, other than 1, was there a common factor between all the terms? No. But if you look at this problem, is there a common factor between all the terms? Other than 1. It's 2, isn't it? So as a general rule, and I'll lay this out in a more general set of steps later on, but as a general rule, you always factor out the GCF first. It'll make your life a lot easier. So let's do that here and then see what's left over. So if you factor out a 2, factor out the GCF from 2y squared minus 2y plus 12, what do you get? Y squared minus y plus 6. And now it is of that form, right? A, in this case, times y squared plus b times y plus c, where we're going to consider a to be that 1 right there. So what's looking just inside the parentheses, what's b, what's c? B is -1 and C is 6. Okay, so then let's set up the reverse FOIL, but you know what? You should really write down that GCF of 2 so you don't forget it right away. Write it out in front and then set up your two parentheses. So write the 2 in front of the set of two parentheses and then write down the two parentheses to set up the reverse FOIL. What's going to be the first term? So think first, outer, inner, last. What's going to be the first multipliers? Y and y instead of x and x, right? And then you need two numbers whose product is 6 and whose sum is what? -1. I put the 1 in there with the minus in front. Think of it as -1 as the coefficient of y to the first power. So you got to get the negative right here. Okay, first of all, if the last term is a +6, what does that say about both the signs in the first and second set of parentheses? They both have to be negative to get a +6 in the end, right? Okay, so they're both negative. And then you want two numbers whose product is a +6, but whose sum is a -1? Ooh. It's not going to happen, is it? Okay, think about it. What are the factors of 6? Yeah, I mean either 6 and 1, right? Or 3 and 2, or 2 and 3, right? Sometimes you have to reverse the order, but not in this case. 6 and 1? Okay, fine. If you want to include the negative, you can. Right? I don't think it's going to matter. It's not going to work. So take -6 and -1 then. Yeah, they do multiply together to make +6, right? But do they add together to make -1? Absolutely not. Take -3 and -2. They do multiply together to make +6, right? But do they add together to make -1? No. So what are you going to say? Well, I mean, we're not solving an equation, so I wouldn't say no solution. I would say it's that where we factored out the 2, it's factored all the way, right? So if you're asked to factor this thing, you would just write it as 2 times the quantity y squared minus y plus 6. And then we could make a note that this trinomial here inside the parentheses, we would call that prime. Like a prime number, the only factors that a prime number has are itself and 1. A prime polynomial doesn't have any factors other than 1 and it's so. So it's a prime. Y squared minus y plus 6 is a prime polynomial. Okay, so the answer is just that.